Welcome to Introductory Logic, Lesson 2, Genus and Species. So we're still talking about definitions and how to define words clearly so that we can use them in logic and reasoning. So the way that this is set up, it is a hierarchy, and it's similar to what you would think of in biology. If you remember the biology hierarchy charts, there's things such as family, order, class, phylum, and kingdom. This looks similar to that, but it is not. For logic, we only have two categories, and they are genus and species only. And we're going to look at some charts and to see what that looks like here in a minute. So again, we're still defining terms, and with genus and species, we're able to define terms in relationship, to see relationship that's going on with terms. So for example, when we define words, what we're doing is usually we will find a broader term to put the word we're looking at to define in. For example, if I have the word dime, I would define that as a coin worth 10 cents. So I'm defining dime, and I'm putting it in a broader category of a coin, and then stating that it's worth 10 cents. So in that definition, the coin is the genus of dime. Coin is broader than the original term of dime. So here's our first definition. Genus is a term that is more general, broad, or abstract than the original term. So the flip side of that would be the species. Now the species is a term that is more specific, narrow, or concrete than the original. So in this case that we were just using dime, dime is the species of coin because dime is more specific or narrow than coin. So here is an example of a hierarchy chart we have here. All right, so if you see, the first one at the top is food. Below it, we have another category. We have meats, dairy, fruits, vegetables, and grains. Now, that line there, underneath food, is the species of the genus food. So food is more broad than meats, dairy, fruits, vegetables, and grains. So food is the genus, and the species of food are the row of words below it. Now, if you look at dairy, it goes and branches further into another category of words, which is butter, cheese, cream, and milk. So dairy, for those terms, would actually be the genus. So dairy is the species of food, but it is the genus of butter, if that makes sense. So the broader term is the genus, and the more narrow specific term is the species. So this is very important to keep in mind, that a term in this hierarchy chart can be a genus and it can be a species, depending on where it is, what you're talking about. So for example, let me put this back up here. So if I'm talking about dairy again, dairy is the species of food, but it is the genus of butter. And all of these species of food are genera of other species. So, whoops, we could go into each one of these. Fruits, we could go branch that down, vegetables, etc. So that is the genus and the species. So we're going to look at some more of these here. Now, with the rules of a species is that the species has to be mutually exclusive and exhaustive. So what mutually exclusive means is that the terms within the species do not overlap. Let's see. Let me use this one. So for example here's another one. We've got logic, and it branches down into informal logic and formal logic. Informal logic and formal logic are totally separate. There's nothing about them that overlaps. So these would be mutually exclusive. And another thing is that it's exhausted. So there are no other forms of logic. So we have exhausted the list. This is all that there is. One thing to keep in mind is that, like, this is theoretically, it could be exhaustive. You could list everything out. However, a person's knowledge is typically not going to be exhaustive. So while it's possible that the species should be able to be completely listed out, theoretically, that is the case. However, practically, a person's knowledge usually isn't going to fill that list. It'd be really hard. But you would be able to if you had all the knowledge. So that's the difference there. So looking back at this one again, there's also another thing called the dividing principle. So this means, how are the terms within the species divided? So if we look at this one, we have divided our genus here, logic, into informal logic and formal logic. So when we divide it like this, the dividing principle is how directly related to reasoning is the term. And if you remember back in our definitions in the first introduction, where informal logic is indirectly related to reasoning because it's definitions and relationships with terms and statements, whereas formal logic is directly related to reasoning because it deals with the rules and such. So the dividing line for how we divided logic here is how related is reasoning to the term. We could divide logic differently with a different dividing principle as we've done here. So this time we still have the same term, which is, this would be our genus, but we've divided it differently. This one would be our dividing principle is what is the product of the or the goal of the term. So if you remember also from introductory lesson, where we discussed what logic is the science and an art. So we've divided here as, on this side, logic as the science is the rules of the reasoning, and over here on this species term is logic as an art, which produce persuasive arguments. So you can have one term and divide it differently and have different species listed. So it's very important. This dividing principle is very important to think about when you have a term. How are you categorizing it? Now, there are some errors that can happen when we are categorizing our charts here. So error number one is to overlap species, which, remember, the species have to be mutually exclusive. They cannot overlap. So if they overlap, there's an error there. Here's an example I have for this one. So I have my genus, my first term, my genus here is people. Below it, for my species, I have listed women and lawyer. Now this one is overlapping because lawyers can be women, women can be lawyers. So they can overlap there. There was a different dividing principle happening, and that's why we have this overlap. So over here, when I put women, I divided people by gender. But over here, I divided people by profession. So you have to have the same dividing line. That's the dividing principle. So this one would be wrong. Another way you can overlap the species is by putting them in the wrong place. So again, we have logic here as our term, that is our genus, that is our broad term, and our species, which is our narrow term. We have formal logic and induction. This is wrong because they overlap, because induction is actually a form of formal logic. So actually this induction would have to go below formal. So this one is wrong because induction is a type of formal logic. So it's in the wrong location. It's overlapping. Another error that can take place is for ambiguous terms. So remember what we said ambiguous terms were last time. It is vague. It can be used, it can be used in multiple ways, which is vague. Okay, so let's say I have this one here. Our term is ball. Ball is an ambiguous word because it has more than one meaning. And if you see, we've actually, in our species line, so ball is the genus to baseball down here. Baseball would be what we're putting as the species, the more narrow term under ball. However, we have baseball and we have winter ball. These are not the same thing. What we have done here is we've taken our term ball and we have looked at two different definitions for it. So for baseball, which is a sphere or toy, we divided ball by sphere or toy for baseball. However, we divided ball as a formal dance for winter ball. So we are taking one term, but we're not remaining consistent with our use of it. Remember, in one of the and when we talked about the introduction of logic and the rules, you have to be consistent. We were not consistent here. We divided it differently. So this is an error because we started with an ambiguous word and divided and used the two different definitions of that word to make the species. Wrong, can't do that. We could have done ball here and continued with our dividing principle of sphere toy and made a species list of baseball, basketball, soccer ball, pickleball, tennis ball, etc. Or we could have made a species list of winter ball, spring ball, homecoming, prom, and those would all be formal dances. We'd have to pick one or the other, basically. So this is wrong because the term is ambiguous and we switched up how we were dividing it. Another error you can do is part to whole. So for this one, we have this example here. This is a bicycle. So bicycle is our term, and it's our genus for the two below it. If you notice, we have frame and pedals down there. Frame and pedals are parts of a bicycle. This is wrong. You cannot create a hierarchy chart, genus and species, and use parts of the term, because that's not the hierarchy we're looking for. A species is not part of a genus. A species is a type or kind of that genus. So we could do, instead of the parts here, how we could fix this is to say mountain bike, speed bike. I don't know enough bikes to even be able to do that one. All right. So again, this is the genus and the genus and species hierarchies, the charts. And remember, this is in order to define terms and to get the broad picture of where that term fits, or the more specific. What you're doing is you're trying to find its categories, higher and lower. And what's really cool about this is again in the pursuit of figuring things out. And there's a really cool quote in the book that I'm just going to read. So the goal is to keep going as high as you can, or to keep going as low as you can, to get more broad going up, more narrow going down. So what would be the end? What would all things come to an end in? And so I'm going to just read this quote. If the process of finding a further genus for any genus cannot continue indefinitely, it is reasonable to ask, what is the highest possible genus? If the genus of food is material, what is the genus of material? Possibilities include matter, substance, being, and so on. All of these things are created. But anything not created is God, since God alone is uncreated. Thus we are led to what theologians call the creator-creature distinction. All things are either creator or something created by the creator. These are the highest genera of things. And I think that's pretty cool. And so remember that the reason that these were set up by first the Babylonians and the Egyptians, and then later the Greeks, was because they were in the pursuit of discovering what is true. And so they were working diligently to look into things and to categorize them and to keep going and until they can reach what would be the highest level. And in this, it would be creator or created thing, or to keep going in the more narrow and to see how much can we break down each thing. And I think that's pretty cool that when you're looking at these things, they all keep going until you reach to the top, which would be created thing or uncreated thing. And the only uncreated thing is God. And so I just think that's pretty cool and a cool way to end it there. So again, this is Introductory Logic, Lesson 2. We'll see you later for a next lesson.